Okay, everybody, here's our next chapter. Chapter 7 is going to be on rational functions. Now, the word rational means fractional. Okay, so a rational function specifically having the various functions that we'll talk about. But first, let's just review a couple things about fractions really quick. Remember that fractions need common denominators when adding and subtracting. So if I want to add up these two fractions, I get a common denominator, which is 30. So multiply this by 3 over 3 and by 5 over 5. So that becomes 25 over 30 plus 20 over 30. Now I can add top, bottom 30, and this can reduce to 26 over 15. Adding needs a common denominator. Multiplying does not. With multiplying, you just go across the top and across the bottom, and then reduce. 45 and 60 can both divide by 15 to get 3/4. With division, you take the second fraction and you flip it over and you multiply. So I'm doing 5 6 times 10/9. If you want to start cross-canceling in advance, you can. Like 6 and 10 could reduce by 2. But you can also just multiply across the top, and I get 50 over 54, which is 25 over 27. Okay? Quick fraction review stuff. Here's a quick review of lines also. Horizontal line equals a. Like if I have the line y equals 3, that is a horizontal line crossing the y-axis at 3. Vertical lines are x equals. If I have the line x equals -2, that's a vertical line crossing the x-axis at -2. So when it says x equals -2, think of that as cross the x-axis at -2. 3, think of that as cross the y-axis at 3. Okay, there's some review that we'll need for this chapter, but let's start going. I'm going to graph the function y equals 1 divided by x. Now this function has a few pieces that I need to be aware of. Here's the most important thing to understand. I cannot plug in an f value of 0. If I plug in a 0, I get 1 divided by 0, and 1 divided by 0 is undefined. So I cannot graph an x value of 0. Like, there will be no y-intercept here because I can't plug in a 0 for x. Since I can't plug in a 0 for x, I can't touch the y-axis. So this graph will have no y-intercept. But I can plug in numbers around x. I'm sorry, around 0. So I'm going to plug in numbers that are a little bit bigger than 0. I'm going to do like 0.5, 1, 2, 3. And I'm going to plug in numbers that are a little bit smaller than 0. Like -0.5, -1, -2, -3. Now, plugging in these numbers might seem kind of difficult at first, but if you just go through it step by step, you'll see it's actually quite straightforward. I'm going to start with numbers that are bigger than 0. So this is me plugging in numbers for x that are bigger than 0. We'll say I plugged in a half. If I'm doing f of 1/2, that means I'm doing 1 divided by 0.5. And actually, the easiest way to do this isn't as a decimal, but as a fraction. Because when you divide by a fraction, you flip and multiply. This actually becomes 1 times 2 to get out of 2. Like, the question is, how many halves fit into 1? So I have the point 0.5 comma 2, which is right. And if I was to do like f of a third, I'd get out 3. And if I was to do f of a quarter, I would get out 4. So I have points here and here also. In fact, these points are going to shoot up like this. Okay, let's plug in 1. If I do f of 1, I'm plugging 1 in for x. That's 1 divided by 1, which is just 1. Here's the 0.11. If I plug in 2, I get 1 divided by 2, which is a half. And I can keep going down like this. F of 3 is going to get me a third, and then a quarter, then a fifth, and then a sixth. And something really, really interesting happens here. I'm going to draw that a little better. This graph, as it goes to the right, is going to keep getting closer and closer to 0, but it's not going to touch it, right? I can make my x value as big as I want, and my y value just gets really small. But it's never going to become 0. This is called an asymptote, okay? An asymptote is a line that a graph continuously approaches but never actually touches. As x gets bigger, 4, 5, 6, 7, 8, 9, 10, this is going to keep getting closer and closer and closer to the x-axis, but never actually reach 0. This has a vertical asymptote at the line y equals 0. Sorry, I said vertical, it's horizontal. But there is also a vertical asymptote. Because also, here, at this part, we're going to keep closer and closer to 0, but we can't touch it. We can't touch it because x can't be 0. So this has a horizontal line that the graph never touches, and it has a vertical line that the graph never touches. And so this has two asymptotes. Now if I plot negative 0.5, negative 1, negative 2, negative 3, in this case it's really nice. Everything just flips. So I'm going to get the points negative 2, negative 1, 0, 1 half, 1/3. Negative 1 half, negative 1/3. So the other half of the graph is just over here. Is the graph, the blue stuff is showing what the graph can't be. This graph has a domain of everything except 0. The x values can be everything except for 0. And this graph has a range of everything except 0. Okay. Asymptotes are lines that a graph continuously approaches but never touches, and hyperbolas have two asymptotes, one that goes up and down and one that goes side to side. Okay, let's look at these expressions here and see what x cannot be. What can x not be here? Well, in this one, x cannot be 0. Because if x was 0, I'd have 3 divided by 0, and that's no good. And in this one, x cannot be 0 for the same reason. I'd have 5 divided by 0, and 5 divided by 0 is no good. And in this one, x cannot be 0, because then I would have negative 2 divided by 5 times 0, which is still negative 2 divided by 0, and that's no good. But in the next ones we have, 0 isn't a problem. Like in this one here, if I were to plug in 0 for x, I would get 3 times 0 over 0 plus 1, which is 0 over 1, which is just 0. 0 on top is okay. It's not a concern. So for this one, what x can't be is something different. X can't be negative 1. Because negative 1 plus 1 is what gets us 0, and dividing by 0 is a problem. And for this one here, x cannot be 5. Again, because if you plug in 5, 5 minus 5 is 0, and division by 0 is a problem. Having 0 on top of a fraction is okay. Having 0 on the bottom of a fraction is a big no-no. And so for this one, there's no x on the bottom. Since there's no x on the bottom, x can be anything. X can be any real number. Because at no point are we dividing by 0, so that's not a problem. So knowing what you can't divide by is really important when you're graphing. Like, let's look at this function here. I want to graph